Okay, this video is the beginning of notes for modules 31 through 35 on thinking, language, and intelligence. So we're going to start with module 31 on thinking. So to begin with, we have to define cognition. So cognition is kind of the theme throughout these 5 modules. And cognition is the mental activities that are connected with thinking, remembering, and communicating. So the modules, it doesn't sound like they're very connected. You know, I said that modules 31 through 35 is thinking, language, and intelligence. Well, the thinking part is obviously the beginning part having to do with cognition, what's actually going on in your head. Language is the communicating part of cognition, and intelligence is kind of the remembering and the thinking part. How do you actually use information? And so cognition actually uses all of them. Now, if you remember when we talked about developmental, we talked about cognitive development, and we talked about how your thinking develops over the course of your lifetime. And do you remember the developmental psychologist, the cognitive developmental psychologist that was associated with this? I'll give you some hints. He talked about schemas and assimilation and accommodation and object permanence and conservation. His name starts with a P. Piaget, anyone? Okay, he fits into this. Now, first, before we go in and talk about any of those things, so we have to talk about how we organize our thinking. So our thinking is organized by concepts. So we organize our thinking by grouping similar ideas together. So for example, we could talk about sports. Okay, so sports is a concept. It's a general broad umbrella, if you will. And so we can talk about within the concept of sports. Obviously, we have different types of sports: basketball, baseball, softball, football, tennis, all these different things that are within that one concept of sports. Now, we do have hierarchies of concepts. So, for example, with sports, some people go and, say some sports are better than other sports. We won't go that route because that's not a very traditional method. Nobody across the board, people don't do that. It's organized the same way. Okay, so we'll talk about hierarchies as far as if you win, for example, a whole bunch of games or meets or matches, you'll maybe go to the city competition, the city of Indianapolis, and you'll compete in the city competition against other schools or other teams or individuals within the city. And if you win that, then maybe you'll go on to the state competition, right? And you'll try and compete within the entire state against other people in the state of Indiana. And if you win that, then you go on to nationals, right? And you can compete against other people in the entire country, okay? So there's our hierarchy. Now we also have prototypes within our concepts. So prototypes are this mental image or this picture that incorporates the features of a specific category. So obviously within sports, when you think of sports in your head, you can think of your brain as being kind of like this Google images of all of what your prototypes are of that particular concept of sports. So maybe you have something like I have a picture here of all of these different sports equipment, okay? Maybe, for example, you think of a particular kind of person or a particular specific person that goes along with a sport, okay? So concepts can be helpful, and they can help speed our thinking if we kind of group and generalize things, but it can also lead us astray. So for example, if we're going with this continuing sports example here, if you've ever heard people talk about like a body type and saying that a specific, oh, your body, you look like a runner, right? Or you look like a basketball player, or you look like a wrestler or whatever, okay? Those are, concepts. We have this concept in our head of, what a basketball player or a gymnast looks like, okay? But the problem is that sometimes it leads us astray. For example, has anybody ever seen this woman before? Her name is Janet Evans. If you don't know who she is, that's good. Okay, Janet Evans was an Olympic medalist in her sport. She is 5 feet 5 inches tall. She's about the same height as me. She's much thinner than I am, though. She is 119 pounds. So, based off from her picture and the information I gave you, what do you think her Olympic sport was? Most people would say gymnastics, right? Or I had some people say something about figure skating based on her size and that she's small, she doesn't weigh a whole lot. But actually, and this is where your concepts lead you astray, she's a swimmer. She was an Olympic medalist in swimming. Swimmers are generally, your concept of a swimmer is generally a very tall, lanky person, right? Because it helps them be able to get from one end of the pool to the other quicker. But she was actually a fairly short swimmer. She had a different style of swimming than compared to other people, but it was obviously very successful for her. Okay, so the point is that concepts can sometimes lead us astray. Sometimes, your prototype in your head of what a swimmer looks like or what a basketball player looks like, for example, doesn't fit with all of the examples out there. Okay. All right, so when we continue talking about cognition, we can also talk about problem solving. So when we problem solve, we use one of three things. First of all, we could use algorithms, and these are procedures that guarantee a solution. But the problem is it's very time consuming. So for example, have you ever done a word search? This is an example of a 50-state word search. So you have to try and find all 50 states in this word search. So how do you approach word searches? Okay. My kids have these all the time when we go out to restaurants and they have like a kids menu and they're all like, oh, I can't find it. I can't find this word. Can you help me? And I said, okay, well, let's go through it. All right, what's your word? And this is 50 states. Okay, maybe you're looking for Alabama. Okay, what are you gonna do? You start at the top and you go through the word search. And you look A. Where's the A? Where's the A? Okay, here's an A. Then look around the A. Is there an L? And then the next letter, and so on and so on. That's an algorithm. Okay, it's a step-by-step procedure that's going to guarantee I'm going to find Alabama that way. Okay, but it is very time-consuming. Whereas I could use a heuristic where this is going to be a more simple strategy. It's going to be you're making judgments. You're kind of skipping some of the steps on the algorithms. You're skipping those steps to be able to make some assumptions off from things, some judgments off from things. The only problem with this is that it can be prone to error. Okay, and you can make mistakes that way. For example, let's say that in my word search, I'm saying, okay, let's see. Well, there's some states that are really, really long, right? Really long name of the state. Like, for example, if I'm looking for California, okay, maybe I'd say that, there isn't very many columns in this word search. There's more rows, and so it's the chances are that California is probably a vertical word, right, rather than a horizontal word. And so I'm going to stop. I'm not going to look for California as a horizontal word. I'm going to assume that it's going to be a vertical word. Okay, that's a judgment. That's a judgment call. It skips steps. It can be a lot less time consuming, but it's prone to error. Okay, what if California is a diagonal word, for example? Okay, so heuristic is going to be that simple strategies where we're making some assumptions to kind of skip some steps. Okay, this is another example. Did you have one of these when you were a kid? I remember these things where they were these plastic little toys, right? And each of these numbers, it'd start off with this, and it looked like this, and each of these numbers was a little plastic square, and you were supposed to move, and this would be like a free space, right? And you're supposed to move the numbers around to try and get it to this point where all the numbers are in order, okay? You could try and use an algorithm where you work at one number at a time. So I'm trying to work one all the way up to this top left position, or I could use a heuristic strategy where I'm trying to basically move all the numbers at once to try and get them all at the same time in the right position. Okay. Now you can also have what we call insight, where you have that sudden aha moment, sudden realization. Word search, Okay, you're looking at it and aha, all of a sudden I see the word Alabama in the middle there. It's just plain as day, right? This also happens when you encounter problems and you've been looking at it for a long time. I just can't get it. You step away and then you come back and you look at it and you're like, oh, I get it. Why didn't I see that before? And it's that light bulb moment, okay? Last thing that I want to talk about is difficulties in problem solving. So sometimes it's you encounter difficulties in problem solving these are some of the things that set you back from finding the solution. So for example, we still have that confirmation bias, and we had talked about confirmation bias before, where you're trying to basically you're finding things that support what you already think you know. Prime example of this, MSNBC versus Fox News. Okay, if you talk to anybody who is a Fox News watcher or somebody who's a MSNBC watcher, this also applies to CNN, okay, they will tell you that, oh, I only watch Fox News because those other news networks are biased, right? Fox News has a very conservative bent, okay? Fox News has a very Republican-leaning broadcast, whereas MSNBC and CNN has a very liberal bent and a very democratic bias. And so what happens is that those people that watch Fox News are conservatives. You will not find a liberal that's watching Fox News, because you are going to find people that they're going to want to watch the show that follows what they already believe. Okay, you're not going to have somebody who is conservative watching, for example, CNN or MSNBC. You're going to watch those things that follow what you already know. You also have problems, and problem solving can also be fixation, where you can't see a problem in a new light. You've been working at it, and you're just doing the same thing over and over again, which is also what we call mental set, where you're approaching a problem the same way you've always approached that problem. For example, we just talked about in memory how the spacing effect, that you're going to find better success in incorporating information into long-term memory if you space out your studying, if you go and review it slowly over time. But I can guess that for your quiz when on memory, you probably didn't do that, did you? Okay, you already probably have your set way of how you study, right? Whether it's been successful for you or not, you have that set in your head. This is the way I study, and it's very difficult, and you get this fixation, and it's very difficult to change. I also have a little cartoon on this. I like this because I'm also an economist. So this one says, these are obviously some cavemen, and they have this big wide gap they're trying to get over. So they're doing this catapulting the guy, trying to get him over the gap, and he falls in. He says, ah, and the guys that are up there says, huh, it didn't work again. And the guy says, yeah. And then they said, but the theory is still sound, so they just keep doing it, says the first economist. Keep doing the same thing over and over again, which I thought was funny. Last point that I wanted to make is functional fixedness, and this is the idea that we have this set in your idea in your head of particular objects and only using them in the typical fashion, the usual way that you use them. Okay, and you have a hard time thinking outside the box of using particular different items in different fashions. So, for example, picture online, I thought this was pretty ingenious. Look at it very carefully at it. This is a mixture of some sort of brownie or batter or cooking, I don't know, whatever batter. But look how they mixed it. They have a pair of scissors stuck into an electric drill, and they use the electric drill with the scissors in it to go and mix it instead of an electric mixer. So it's kind of interesting. Anyways, that's the beginning of thinking. Let me know if you have any questions.